cabling work from the local university to the place where we set up the dial-in ports. These were analog modems, very, very nice. Okay, so people could dial in 32. That was the maximum budget we had during the time. 32 people could dial in via an analog modem and use the internet, the World Wide Web. That was awesome. And then after some months, everything got stable. We started to add email. That was cool. Email. People could write someone, and then immediately they received an email. It was also very cool. And history repeats itself. When people started to write email, and the first email addresses we had were from the local government, so they could reach out and ask questions and something. And what people did is they wrote an email, and then they grabbed the phone, called us, because we had some sort of a hotline. Yeah. Hey, I just wrote an email to, did he already read it? I said, well, we don't know. So we cannot go. Why? You should know that. I just sent it. Can't you look that up? And maybe he already responded, but I didn't get the response. So they gave us a call, and we should look up into everything. And this for a very long period of time. So every day there were dozens of calls asking, have you read my email? And today I receive Teams messages. And if I do not respond within a second or something, or 2 seconds, people immediately hit the dial button and ask me, hey, have you read my message? Okay, and that is how history repeats itself. So we are back to the days where people get a call if you have read my email. Now it's a Teams message. Okay, but back to the topic. Okay, AI function call. And we have some theory up front. I'm really sorry, I prepared 170 slides for the theory part.
That's fine.
Okay. No, okay. So 5 minutes speak time per slide. You can do the math. And then we look at what that tool calling is, why it is actually a cool feature, and why it has absolutely nothing to do with the large language model. Okay. And then we do the real stuff. So after we did the 170 slides, we go to some OutSystems thing. Okay. So the basics. Oops. Okay. What's when you look at OpenAI or AWS Bedrock, Anthropic Cloud, so all the large companies that provide large language models, then what's important to note is that you actually never interact with the large language model itself directly. So you never call the large language model on your own. So what you see is an API that is an abstraction across the large language model that sometimes does some additional magic stuff. In the end, a large language model is like a website. You send a request, and the large language model gives you a response. The large language model itself does nothing else. It does not store anything. It does not process anything. So in terms of, it does not look up a website. So that is sometimes a myth that people think, oh, I give my data to the large language model. No, you don't. You can't. It's a read-only model. You send in a request, and you get a response. But of course, all those providers like OpenAI, like Anthropic, and so forth, their abstractions, they do store data, and they do process data, and they do call maybe some other things to enrich the response or give you additional features which the large language model itself does not provide. So that is very, very important, and a good example is the chat completion API of OpenAI, because this abstraction across the large language model, you see nowadays basically for every other large language model itself. It became a de facto standard on interacting with a large language model, and that is you have typically a system prompt where you can give some basic instructions, then you have a user prompt representing a user question or a user query, and then you have an assistant reply with whatever the large language model comes up with additional features. So in the past, you could do that with text only. Nowadays, you can also do it multimodal, so you can enrich your query with images, videos, audio, and every week something new comes up. So, and that is my saying. If people say, okay, should I wait for the next generation of large language models or tool sets or whatever? And I say, it doesn't matter. You can start anytime, it will be outdated tomorrow. So, and that's it. But it's important to note, so a large language model is just you send in something, you get back something. The large language model itself does nothing. And all the abstractions you can basically build on your own using your own runtime engine. And for us OutSystems and C# guys, any C# developers here? With a smile. With a smile. You can easily, run a large language model using the ONNX runtime from Microsoft by using C# code. So you download the model, add the runtime Nugget packages, and then prompt it on your own, expose it as your own service, make your own abstraction, run it on CPU if you have the time. I mean, if you're not close to retirement, then you can run it on CPU, something like that. Okay. So the challenge with large language models, and that's really a challenge, that large language model, when they produce a result, that is true by, let's say, by statistical accident. So it's just large language model produces an answer based on statistics. So one word, the large language model can infer that a certain arrangement of words produces a proper result based on what has been given to the large language model. It's not that the large language model does not think. It's not a real intelligence. It's just, in the end, it's statistics. The challenge is no one can tell you how it really works. But the challenge is that if the answer is right, you send in one prompt and you receive a response that is right. That this does not mean that the large language model is always right when you send in the same request a second time, or a third time, or a fourth time. And when people talk to me and say, hey, I tested it 100 times, and the large language model was always right, then I say test it 101 time. And because at a certain point you will see that the answer is inconsistent. It starts to hallucinate and whatever. Okay, so, and that is a big challenge when working with large language models without proper additional features. And two of the most prominent possibilities to reduce the likelihood of hallucinations or giving incorrect answers based on a query is this one, retrievable augmented generation. I like that, retrievable augmented generation, RAG. That sounds really cool. Cool. Does anyone know what RAG means?
That
was awesome. If I had a giveaway. I mean, you could just read it, but it's okay. Retrievable augmented generation means that you retrieve something from a well-known data source you created. So You retrieve curated data from a source. You augment, meaning enrich a prompt. So the prompt becomes bigger. And tell basically the large language model, hey, here is curated information from my well-known data source. I know that this is true. Please create an answer, but only on this information. Do not add additional information and something else. There are several standard prompts you can use for this retrievable augmented generation to prevent hallucination, because you only say use this. But this is not entirely true, unfortunately. It's really, it's a pain, because you heard that the next large language model has a so-called context window of 1 trillion tokens. It's unbelievable. A single prompt can contain the knowledge of the world. But it is known that the longer the information is that you pass in to a large language model, the higher the likelihood is higher that it again starts to hallucinate. So you want to keep your context, so that's the information you pass as a single request to the large language model, as minimal as possible. So that is the biggest challenge in that REC pipelines. And there is another, I always give the example when people, bless you, when people build up a REC pipeline based on company knowledge. And one good example I always take is you have a policy document. You add it to your SharePoint, and then it gets indexed and something, okay? And that policy statement says, you are allowed to take presents up to 20 euro. That's one of the company policies. Now someone else comes up and creates a copy of that document and calls it version 2, but saves it in the same location where it still gets indexed. And he changes the policy and writes now, you are not allowed to take presents from customers. That's it. So that's a new policy that overrides the old policy. But in that retrieval task, now your retrieval would inject both information. So it's now two concurring information, which could lead to a response like, yeah, you can take presents up to 20 euro, but not from customers. That would be the result. And that is why this retrievable is so important, that you have a proper knowledge management, and why it's all about curated information. So really curated information in something. Okay. REC is the only way to ensure that you only produce facts. It's the only way. Now, because this one, model fine-tuning, you read that all the time. Give me lots of data, buy a GPU cluster, train your data. That's what typically data scientists come up with. They want you to train a large language model, to fine-tune a large language model. But this type is not for producing facts. Facts you only get with REC. Here you get a more, either a model fine-tuning is targeting a specific style of an answer. So let's say you always want the large language model to respond in medieval something. Okay, then you can fine-tune on that part. Or you can fine-tune a large language model to be able to detect certain entities of your company, like product names and something. So that is what you can do. But in the end, what you do is, so the large language model, when you first download it or when you first use it, it has a certain knowledge corpus. And you are adding to that knowledge corpus. So you're adding additional knowledge. But in the end, it doesn't help you to produce facts, because it generates words based on statistics and adds it to the answer. It could also lead to that you fine-tune with additional knowledge and you're making things worse. and it starts to hallucinate much more earlier. Okay, this is why it's so an interesting topic, because there is no way where you can say do it like this and it always works. But there is no. It's mostly trial and error. That's why they are called data scientists, because they do research. They try until they found something where they think, oh no, I think it's working. Okay, so a little bit more in detail. For RAG, you need a so-called pipeline, and a pipeline is basically actually it's simple, but there are so many variations now available. But let's focus on one. So you have data, you have source data, and that source data, in the end, you have to create some sort of text out of it. So, or you have to have individual images or whatever you have. And text is complicated because you can express things in different ways. But if you compare words, if you compare word by word, then you don't find specific sentences because although they would mean the same. So what you do is first that you vectorize data using an embedding model. What is an embedding model? An embedding model is a large language model or a small language model, doesn't matter, that creates a multi-dimensional vector out of the text you give to the model. And this vector is a semantic representation of what you put in. So, for example, you put in, I like scuba diving. Okay? And if you would search, if you, in a classic search, in a word-by-word search, if you would search now for what is a nice underwater activity, you wouldn't get the scuba diving text, because there is no equivalent on a word-by-word search. But on a semantic search, if you have a semantic representation of both of the question and the I like scuba diving, then semantically they are quite equal because both are somehow related to underwater activities, and then you would get the result. And that is why you vectorize data and ingest it in some sort of store. Vector databases are quite popular. Azure AI, that is what AI Agent Builder is using. Amazon Kendra, also supported by AI Agent Builder, to store this in memory. And then you retrieve it. So retrieving is you write something, which also gets vectorized, and then compared to the stored vectors you have, which returns a pile of findings. And that findings, you need the equivalent text for that findings. That is what you then augment, meaning inject in your prompt. And then you tell the LLM, take the information, take the question, produce an answer. And that is all the magic. It sounds more complicated as it is done, of course. Okay, so this is more, I know it's small, but this is how it actually works. So you have an input text, which gets vectorized by OpenAI embeddings endpoint, for example, or any other large language model, doesn't matter. Then stored in a vector database. Then you have a question or an instruction that it gets also vectorized. A similarity search is performed. The resulting text is injected into a prompt with some common instructions and the question provided, and then using the check completion API endpoint to produce a tailored result. That's all the magic. Nothing more. So that's it. I'm done. Okay. No. Okay. So now the interesting part. So that is standard retrieval augmented generation. You take text, inject it, and then let the LLM produce a result. Now, a tool is actually one form of retrievable augmented generation, but with an additional feature. Okay, so think of a rec workflow uses an index you have prepared, so from documents or something, and you inject the information into your prompt. This type would not help you if you would ask, what is the current temperature now in Utrecht? Because there is no document that has that information. What is the current temperature in Utrecht? So you would need the large language model would need the option to call some sort of weather API or something to get the current weather. And in order to get the current weather, it would need some sort of information. So, for example, the city. So, and if I say, what is the current temperature in Utrecht, it should already know, because I already stated the city. But it could also be that I say, what is the current weather? And then I would expect, a real person, I would expect to ask me, where? Where? And this is exactly what tools are providing. Okay? So tools can be anything. So you can declare a tool with some instructions, with some mandatory and optional parameters. And then is then the LLM calling a tool?
No.
And why not?
Because the LLM only contains the trained data. It is the API around the LLM that does
Correct. Correct. So, and that is always very important. Not the LLM is then calling a tool. That is your responsibility. So what the LLM does is it has all that tool data definitions. The tool definitions we see in a bit, and then it reasons over that tool definitions to find out if one or more tools are applicable to call, but it doesn't call it. Then it determines are all mandatory parameters that are part of this tool definition are part of the context of what I have in my prompt. If so, it returns to you, so to your application, hey, call a tool. The tool name is taken from the definition, and the input parameters are city, Utrecht. Do that. If I didn't specify Utrecht as city, the LLM would say, hey, I want to call a tool, but I'm missing one mandatory input parameter, the city, and it would respond with, please provide the city, which is pretty cool. But the tool calling itself is up to you. So you call whatever you do with that information, and then you return to the prompt. So you generate an enriched prompt with the result of the tool call, returning the information. The temperature is, I don't know, 21 degrees. And then the large language model produces the output. Okay? And if you think this is really complex, sometimes it is. Because you have to think of, okay, but there could be parallel tool callings, or one tool could produce the input parameters for the second tool, and something. This is where it gets really complicated. So it's really nice to see. Sure.
So rec is a known term used in AI. Is tool also a known term used in AI?
Yes.
It is?
Yes. Well, not every, funny-wise, actually every large language model provider, so the big ones, have adopted the tool specification API from OpenAI. Well, that is good news. So the tool definition API, as part of the prompt, is equal from OpenAI to AWS Bedrock Converse to Anthropic, so they're all using the same. but not everyone is calling it a tool.
Okay.
But in the end, everything is a tool. So it's, some call it function. Sometimes you see, like here, function calling. So it depends on the provider you're using, but in the end, everything is a tool. So, I already explained that. So it's pretty simple. So we can start with the real stuff. Okay. I can sit down, right? Let's see. Oh, I should have started Service Studio before. But that is always a quick action. What I'm showing is a demo application, and that is available for both OutSystems 11 and ODC. So you can download it from the Forge, which includes a very, 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 very basic tool function calling example using OpenAI. I took OpenAI, although I'm more into that AWS stuff, but I think it's more easier to get an API token from OpenAI than dealing with AWS credentials and something. So that is why I use this. Okay. So, and that's the name, OpenAI function calling sample. I made the logo. I'm meanwhile pretty good in that Inkscape. That is an open source software, you know, for creating illustrations, vector graphics, and so on. I really got a habit for it. Okay, so what we have, and I have, so what you see here, that is a REST consume operation that integrates with OpenAI, so with the OpenAI specification. And there are parts you may already noticed, you know, so the request contains a model parameter and, you know, a temperature that specifies how artistic an LLM can answer, okay? And this messages block, which is always a role. A role can be assistant or user, you know, something like that. A content, so that's the text. We have these tools calls, parameters. So that is pretty a pretty large part. And that is even more important. At a certain point, when it comes to these properties here, so properties are the mandatory input parameters of a tool call. This is where you go into dynamic JSON. And it's, I don't know how many have dealt with dynamic JSON, so where the attribute name can be dynamic, can be anything. Okay, and in OutSystems we don't have that option. So we don't have a key option we can use. So everything must be statically typed. And this is part of the demo. So here are the input parameters are statically typed. So that is why you have to create your tool definitions basically on demand. Or you're using tools to transform JSON. There are some Forge components where you can transform dynamic JSON into static JSON, but it's more complicated, and I try to skip that here. Okay. But let's see how this is actually working in Postman. And Postman is your friend for tool function calling because it's more visible than the structure list. If I explain too much, you let me know, right? Okay. So what we have here. So this is one example call. And now you know why I said, what's the weather? Because that's the example. So we have a call to the model GPT-4o. That's one of the newest models that came up from OpenAI. And we have a system message. You are a personal assistant. You answer all sorts of questions in a helpful manner. That's basically a nonsense prompt, but everyone is using it, so I'm using it too. But these types of prompts are totally useless. Okay, so I always smile when I read prompts like please be polite, please. I mean, why should I say please to a computer? So it's nonsense. Okay, so it's totally nonsense.
Wait till they get intelligent proof.
Yeah, remember. We have to wait. But today I would say it's not necessary to say please and thank you and have a good night.
They will remember.
And then we have this user thing. Okay, so the user is now asking a question: what is the weather? And down here we have the tool definitions. So the tools is an array, and we have now one tool of type function. The tool name is weather tool. The description, and this is the most important part of a tool definition, is to write a proper description, because this description is used by the large language model to determine if a function should be called or not. Okay, and then the parameters. In that case, that's the city, which is a required parameter, the name of the city. And this call here now is what is the weather, does not provide the city. Let's see what comes out. Okay. Now the response is that where is it?
Line 11.
Oh, here.
Yeah.
Okay. So the response is now that the assistant said, so that's the response, to provide you with the current weather, I need to know the name of the city you're interested in. Could you please specify the city? Okay, so that's pretty cool. So that it basically meant it determined it needs to call a function, but it is missing a mandatory input parameter, and it's returning in natural language what we need to provide. So this is something we can immediately give back to the user. Okay.
And politely.
Politely, very polite, and please and thank you. Okay. So let's see how this looks like when we answered it. Okay. So in that case, we have your personal assistant. What is the weather? The assistant replied, could you please provide the name of the city you're interested in? And then the user says Berlin. Okay. Okay, we can take Utrecht. Okay. And again, our definition, the definition must always be included. And let's see what happens now. Okay. Now it returns. And as you see, there are now no natural language answers, because the only response we get now is call a tool. That is now an instruction for our application. Call a tool. That is what we have to do next. So it tells us to call a tool with a specific ID. And that ID is really important. With a specific name, so that is our tool name. And the input parameters is serialized JSON. So that is what we get. So every time we get a finish reason of tool calls, it means it does not contain any information we should give back to the user, but we just need to execute now something. Okay. So, and here, that's the next part. Now we called a tool. And as you see, so we again have that system message. We have the what is the weather. The next was, could you please provide the name of the city you're interested in? Then we said Berlin or Utrecht, doesn't matter. Then we add the response of that you need to call a tool, okay, with this specific ID. And then after we ran our tool in OutSystems, in our application, we add another element to the messages cluster of role tool with the content city, Berlin, temperature, 27 degrees Celsius, for the calling ID, which is this one, so that the LLM knows, okay, this belongs together. Because it could be multiple tools, this is where it gets really complicated. And if we start this now, the LLM puts out another message. The current temperature in Berlin is 27 degrees Celsius. I doubt that it has 27 degrees Celsius at the moment, but this is what we told them. And this is the tool calling flow. I know it looks a little bit weird but you always add the last message to the whole message context. And somewhere in between, you call a tool and add this to the message context, and the rest is the work of the large language model. Okay, but this is how it works. And I'm showing this because this is much more readable than that structure you have here. So it's much more complicated.
Is there a maximum to the messages array
Yes,
you can have?
of course. There's always a maximum. It depends on the context window of the large language model. So Anthropic Cloud Sonnet has a context window of 200,000 tokens. Now, what is a token? So that is always a thing. So typically, one dot. So that is for, I only know it for German language. For German language, the factor is a word, 1.25 tokens.
About the same in Dutch.
I would assume it's the
Yeah.
same in Dutch. So in English, I would say it is a little bit less, but 1.25 is good to count. And that is the maximum you can, and that is always, you always have to keep in mind. This one, this context window is the maximum for the request you send in and the response you get. So if you send in 199,000 tokens, then the LLM has exactly 1,000 tokens left for the response. So it's always what you send in and the response, that in total is the context window. But we already heard that today. I know it's a lot of information. I'm really sorry. We already heard that today. You want to keep your context as small as possible. The more context you deliver, the more likely it starts to hallucinate. And that is why I always say, try it out. Try it out 100 times and then one more time. Okay, so in the end, so having this structure, let's try it out first. I hope it works. It's the same like with live coding. You try it out 100 times, and then you start, and then nothing works again. So how does it work? So how may I help you today? Oh, what's the weather? Oh, oops. Sorry. What's the weather?
Yeah.
I didn't provide an API key. Now that is fun. Oops. Okay, well, we do first how it is implemented, and then I think I reinstalled it. Could be. It's an application setting, and then you know how it works. Okay, so what I have here is two tools. So I have this weather tool, and that weather tool has one input parameter, that's the city, and has exactly one result. So city and temperature, this is what it returns. And as you know, in all my cities, it has it's a fake tool. But I mean, I guess you know how to query your database and something, so it's pretty obvious. And I have a product tool, which takes in a product number, and delivers a product number, a name, and a price. Okay, so that's what it's delivering. And those two tools are basically contained in the definition here. Yeah, in the tools definition. Yeah, so I guess you know that. And when that chat is executed, it basically this process tools creates that tools definition. So one for the weather, one for the product. Okay, creating the tool definition returns it. So including proper content text and roles. So that is what it's doing. And more interesting is that send chat. So the send chat, and always think of that you always have to append to the context. Okay, until you get an error message, basically. Okay, so always you append to the context, one message after another, and that is basically you get all this chat thing takes in all current messages like they are, including tool calls and everything. So just basically infinite adds up. Then it adds the weather tool. It looks like this. So the weather tool has an input parameter of string, name of city, something. It's a little bit weird when you make the definition of the tools using these static structures. And for the product tool, and then it calls the OpenAI chat completion with that whole request. And this is basically the only magic in that thing is to check, is the result, now we've seen that in Postman, is the result a tools call? And if it is, we have to process the tool, meaning we have to decide, should we go for the weather tool, should we go for the product tool, and then we append that again to the response, and then we execute the LLM again. And the nice thing is that can be a loop, because one tool can generate the input parameters for the next tool, can generate for the next tool, can generate for the next tool. And what is really a pity is that OutSystems is not able to open up parallel tasks. So you can process one tool after another, but you cannot process multiple tools in parallel. And that is very seldom because people don't write in that way. But it could be. It could be that you have one tool that returns information for a car license plate, and another, so it takes a license plate number and returns information for a car, and a second tool that returns current insurance state for a car. In that case, it could make sense that you execute in parallel, but you can't. That's not possible. So you have some latency in working through that. That differs to these agentic frameworks like LangChain, multi-agentic, and all the gazillion other frameworks in Python you could use where parallel calling is supported. But that is actually the magic. So you go, append. If it's not a tool call, we append it to a response, and that is outputted into our application. And that is all the magic about function tool calling. Pretty easy.
Question.
How do you call the tools?
Pardon?
How do you call the tools in your OutSystems logic?
That is in the process tools. So the process tools is basically, so I know from the response, I have to call a tool. And then I call, then I decide which one do I have to call. That is part of the response. So the LLM tells me, call the weather tool, call the product tool. So I call the weather tool. I deserialize the arguments. That was because I only get this. Always remember, you only get that instruction to call a tool when all the parameters are fulfilled. So you know all input parameters are there. So you deserialize it, and then I call my server action here, which always returns 27 degrees. Okay. Okay. Then I serialize the result because I have to add that to the content. Add that to the result message list, which then gets again added to the messages list of the whole context, and then again return to the large language model. So in the end, if you have 100 tools, you have a very big switch.
You were talking about asynchronous calls. Can it be that the large language model asks for two tools in the
Yes.
same message? So
Yes.
this could break because it will only get the.
No. The fun thing is you would, it already knows that it has to call two tools. That is why they are, and you can write, please tell me what's the weather and return me some details on product ABC.
Yeah.
Then you would receive, I need to call two tools. So the first, you would process the first one and return that to the result. Then the LLM would, you send it to the LLM because you say, okay, I called the tool. Then the LLM will again come with a tool function call because it says, you missed the second one. Okay. Then you do it again, and it just adds up latency because you cannot do that parallel calling, but it will work. So if you come up with 50 tools, it just.
You could also make a loop in this action to walk through all the tools that are needed for this call.
Yeah, you can. You can. Actually, and you're right. I thought of that, but it would just, this one looks pretty clean, but with an additional loop, it would look pretty bad.
I understand.
And it is, it's function calling is, and really to be honest, so if you have 2 or 3 tools you want to attach per, let's call it an agent, then I would say it's totally fine to do that in OutSystems. If you have a multi-agent system with lots of tools and something, no, it's not the right tool set because in the end, because you cannot execute anything in parallel, it would just mean it takes minutes because of that additional round trips from the large language model and back. It just takes too long, and no one wants to wait that amount of time. And there are other frameworks like semantic kernel, LangChain, Llama Index, so many agentic frameworks.
One question, you mentioned when you started describing that you passed the information about the tool to the LLM, and you mentioned that the description of the tool is really important. Is it the case that in order for the LLM to know whether a function call needs to be made, yes or no, that description is being used to assess that? Okay.
Yes. That is why it has to be so good. Because let's say if we describe our weather tool just with returns data, potentially the large language model would never ever come back with an instruction to call that tool because it could not really reason it over it.
So then what the LLM does with that information is to put it in a vector and see if it matches then the.
That is the fun part of it. So of course, internally, large language models work with embeddings. That is true. But in that case, yes, it would do some sort of similarity between what you have inputted and outputted. But to be honest, how it really comes to that conclusion, I would say no one can really tell you that. That is a pity with these large language models that really no one can really explain how a specific request led to a specific response. So everything you read about, we have explainable AI, when you read the explanations, I mean, yeah, you read them, yeah, I based on the first information, I came to this conclusion, and then I came to this conclusion, but why an LLM has chosen this path, you never know. And no one can explain you, and no one can explain you why the first request produces this and the second request produces this. And that is why testing frameworks for AI are unbelievable. Because there are some patterns, where you have 3 different large language models, 2 generating a response, a third one comparing it, and then deciding on it. Because you cannot really test that. I mean, in a unit test in C# it's easy. So you write a unit test, the method returns a true. If it does not return a true, then the assertion is false. I don't know. But it can either be true or false or an exception. There is nothing else. In an LLM, it can be a true or false and something else. That makes it so hard.
I would like to we have just one more question, because you've got some new fresh pizzas in just for a short break or so, and then
I'm really sorry.
Mark can do it.
No, don't be sorry.
If
It's a good thing that we all have questions,
If I
right?
don't have a timer, I don't.
I didn't look at the time.
So on Postman, you indicated on the first request just the indication of one tool, which is related with weather. But what if the question of the user would be, for example, what's the traffic?
Oh, no, that's not the one. Let's go here.
We'll come up with something.
What is the traffic? Okay, we have our tool that returns the weather temperature for a given city. Okay, and now what is the traffic? And it would reply with, I'm unable to provide real-time traffic updates. I recommend using a dedicated traffic app. Like Google Maps.
But does it provide on the tool response an indication that we should? It does not, right?
It does not. In that case, the tool is obsolete because the description doesn't fit anyhow to what is asked for. So the reasoning of the large language model came to that conclusion: no, I don't have to call a tool, and therefore provides information based on its own knowledge. And we didn't make any restrictions.
But then in that case, it's up to you to really provide a large enough number of tools in the first requests so that the large language model can eventually use one of those tools, right?
Yeah.
Otherwise, it cannot reason.
And that is typically done in a system role. So where you say, you only answer weather-related questions.
Okay.
In all other cases, reply with, I don't know. I don't know if that is working, but we will see. So in that case, what is the traffic?
It should say that it doesn't.
I don't know.
It doesn't reply.
But it did correct your spelling error.
Okay.
He has a follow-up question. I fully agree with him. There is a question and then there is a follow-up question.
So for me, then I understand that this is very specific. That this is very specific for a use case. For example, an agent that replies questions about real estate.
Yes.
Then you provide a tool to get information about Funda, which is okay. It's the system prompt that you provided was so generic, then it confused the use case. At least for me, it confused the use case for.
That is up to you. That is why a system prompt is actually pretty important. There was one really bad example, with a traffic cloud provider, very, very popular, really very popular. And they added a chatbot. And there are always people that trick the system. So he said, okay, I need a ride from my location to, but I'm a black person. So that is what he asked. And the large language model responded with, oh yeah, there is a ride, but most likely no one will take you with you because you are related to black people in that area.
True.
But the next day they took down that chip. Okay? But this is what can happen. So if the prompt is not good, if the tools are not good, if the large language model is not good. So, and we always have to think of it is trained on information that is public available. And there is so much hatred public available that all large language models are biased in any way.
Nice.